Hello viewers, welcome to another session of our online class, Preparatory e-learning class. If you are viewing on YouTube, please do well to subscribe. Our topic again that we have for today, still under indices, the subtopic is exponential function. These are examples to show exponential functions or equations. If you have the unknown as a power of a function, because of this, it has made this equation an exponential equation or exponential function. Let's go to question number 7. Question number 7 says, this you have 25 power x, 25 power x minus 5x, 5 power x minus 20 equal to 0. This will take us to quadratic equation, but it's still very, very simple. Now let's see what we can do there. This looks quite complicated because we now have minus sign coming in. No multiplication law, no division law, no power law. So what do? Let us see how we can reduce this base to be the same, 25 to be the same. This 20 is already a number. You cannot reduce 20 into base 5. It's not possible. But we can reduce 25 into base 5. How will that be? What is 25 into indices? 25 in indices is 5 power 2 into x minus here 5 power x minus 20 is equal to 0. So what do we have there again? This is going to give us 5 into 2x there minus 5 into x minus 20 equal to 0. Now look at this. Because we have minus, we cannot still apply the exponential law. Now what do? Let's see what we can do there. Let's make this one to be the same as this. We have 5 power x into power 2 minus 5 power x minus 20 equal to 0. You can see that this is the same thing as this. Why did we have to make this to look like this? So that since the equation looks complicated, for us to be able to solve this, we make another function to represent 5 power x so that we can easily solve it quadratically. A quadratic equation is an expression that the highest power of the unknown is 2. So here, the highest power here is what? 2. So if we say, let 5 power x equals to q. Anyway, you see 5 power x, what do? You put q. Now let us see, take note of this. We are going to bring it back. We want to use q to replace that, and we'll come back to find our x. Don't forget, you were asked to find x, but not q. Now what do? In place of this, we have q squared. In place of 5 power x, you bring in q, and the square there is there, minus 5 power x is what? Q, minus 20 equal to 0. How do we solve that? This is now our quadratic equation. We can use different methods to solve, be it factorization method, be it formula method, be it completing the squares. In this one, let us use factorization method. Now, using factorization method, let's see how we can solve that. Now, in applying factorization method, what do? First thing, multiply the first term there and the constant term. Multiply these two. Multiply that two. Now we have q squared times minus 20 is what? You have there minus 20q squared. Just keep that one. It's not part of the solution. You just keep it somewhere. So that when you find two numbers, two factors to replace minus q, you check whether if you multiply them, if you can have the same thing as minus 20q squared. Just keep that one. You look for two numbers to solve this using factorization method, look for two factors of 20q squared whose sum or difference, sum is answer after addition and difference is answer after subtraction, whose sum or difference will give us minus 1q, minus q, or whose product is answer after multiplication, will give us minus 20q squared. Now, how can we get these two factors? See how to get here. We have 20q squared, you break it down. This is not part of the solution. I'm just trying to get the two factors to replace minus q with. It's not part of the solution. You can do this somewhere on your rough note. Now we have, what can go here? 2 goes here, we have 10q squared. 2 goes, you have 5q squared. What can go again? 2 cannot go again, 5 can go. 5 divided, you have only q squared remaining. Q cancel 1q, you have 1q remaining, and q goes here, you have 1. Now, of all these factors, let us select a set of 2 factors from here such that when you find the sum or difference of them, it gives us minus 1q. Now we have, let's look at these 2 and this one. 2 times 2 is what? 4. Let's look at 4 and 5. You can just put q there and q. 1q goes to the first number and the last q goes to the next number. Now, what do? We now say, let the two numbers be, the two factors be 4q and 5q. The next thing is, what sign, be it plus or minus, should I introduce to 4q and 5q such that if I find the difference of them or the sum, I will have minus 1q. And also such that when I multiply them, I will have minus 20q squared. Now I've gotten my two numbers, my two factors, 4q and 5q. What sign should I bring in? If I bring in plus here and minus here, it will have that plus 4q and minus 5q will give us minus 1q. How? See the how here. Don't forget I told us if you have different signs, minus 4 and, plus 4 and minus 5, if you have different signs, I have said for different signs, you find the difference of the two numbers. The difference of 4 and 5 is what? 1. Now, which sign between plus and minus is attached to the biggest number? Minus is attached to 5, which is bigger than 4. So you have minus 1. So here, plus 4q and minus 5q is what? Minus 1q, which corresponds with minus 1q that we have there. From here, we have q squared plus 4q minus 5q minus this other 20 here is equal to 0. After doing that, we separate using bracket, and the next thing we find the HCF in the first bracket and HCF in the second bracket. So the HCF of q squared and 4q is what? How can we get that? See it here. We break it down. We have here q squared and 4q. What can go there? Q can go. Q can go. Q is the highest common factor there. Q goes to q squared, you have 1q. Q goes to 4q, you have just 4. Because this q cancel this q, 4 is left. 1q cancel 1q, you have 1q there is left. So no other number can go here. No other factor, highest common factor, can divide q and 4. So the only HCF, the only highest common factor that we have for this first bracket is what? Q. So you put here q outside the bracket, open bracket. For q squared, we have just q left here, plus for 4q, we have just 4 left. This other bracket, what is the HCF of 5q and minus 20? Now let's look at it. We have, you still do the same thing, break it down, and 20. What can go? We can see that only 5 can go. 5 goes to 5q, you have just q. 5 goes to 20, you have 4. The only HCF here is this 5. So you have the minus is outside, you put minus the 5, open bracket. What is left for the first 5Q? Only Q is left, you write. Now, this minus, I want to bring down this minus, but you don't bring down this minus because you have minus outside the bracket. Anytime we have minus outside the bracket, whatever sign that we have inside here will change to plus 4. Reasons being that if we open this bracket, minus 5 times Q is minus 5Q, and minus 5 times positive 4 is minus 20. Minus times plus is minus. So anytime we have minus coming with the HCF, opening the bracket, whatever sign you have inside this bracket before must change. And for you to know that your solution is actually correct is the bracket must be the same. To continue from there, we pick one bracket, Q plus 4, and pick the other ones, the factors outside, the HCF Q minus 5 equal to 0. Now to continue from there, the first bracket equates to 0 and the second bracket equates to 0. So we can find our Q. So you now have first bracket is what? Q plus 4 equal to 0. And this other one, Q minus 5 equal to 0. How do we solve it? To make Q to be here alone, you move coordinate like terms here. So what do we have here? Q is equals to what? Minus 4. And Q is equals to what? 5. So these are the answers for Q, but not the answers for X. We were asked to find X, but not Q. Now, what do we do to find our X? We now recall that we had to let 5 power X be replaced by Q. So we have to recall that. We say recall that our 5 power X was equal to Q. So every answer for Q we have here, we bring it inside there so that we can find the corresponding value of X. We are asked to find X but not Q. Now what do we do? For the first value of X, we have at Q equals to minus 4, put it here in this equation star, we now have 5 power X equals to what? Minus 4. You look at this exponential function very well. You can see there's no how you can reduce this 4 to be like this. And here is minus. It looks complex. When you come across this, it's a complex way of solving it. You just say this is invalid. This cannot be solved for the first value of Q equals to minus 4. We now go to the next value of Q, which is 5. We now say at Q equals to 5, we bring in the value of Q as 5 in place of Q in this equation star. We now have here, this is going to be, we have 5x equals to, in place of Q we put 5. Now let's solve. How do we do that? You can see that the bases are the same. This 5 has invisible power 1 because 5 power 1 is 5. Yes, we've not done anything too big there. We are just bringing in 1 so that we can easily have an answer for X when we equate the bases. So the bases are the same. We equate it. We now have X is equals to 1 because 5 power 1 is 5. When we cancel it out, X is equals to 1. So our final answer in this question is that X is equal to 1.